Question number 21. KSP of FeOH whole twice. Any doubts here? No.
Sir, they asked moles of salt, not A plus or B plus.
It is KSP, the rule of moles of this and this in the liter. That means there is a, I mean, what else it could be? Because A which whole twice and B which whole thrice is not going to be in the solution. Okay. So no way they can be as it is go into the solution. Getting it? They could not now because they're solid. So what else it could be? They're basically talking about the solubilities. They are basically talking about the solubilities. See, this is the question,
Yes.
and at the very first time, it looks slightly confusing that what about the ratio of moles of this in 1 liter? And it is clearly given something is happening here that if you're taking these two salts, A OH whole twice and B OH whole thrice, solids of this has been taken. So some amount will pass into the solution. Okay. So basically, we are talking about the amount which has passed into the solution. They will remain like A OH whole twice and B OH whole thrice. Now suppose S moles of that is gone into the solution and S dash moles of this has gone into the solution. So we basically want the ratio of what? S and S dash. Clear? Anything else in this question? This question is slightly peculiar because you see, this is the case of simultaneous equilibrium. Simultaneous equilibrium. Now in the simultaneous equilibrium, since they are solid, basically A OH whole twice solid is there, and you notice the KSP. This is going to give you A 2 plus twice of OH negative, and see the KSP is order of 10 to the power minus 12. So very quickly we come to know that this is something like a 4s s dash cube will be order of 10 to the power minus 12, or basically it is 4 into 10 to the power minus 12. So clearly this S dash is equals to 10 to the power minus 4n. So this is going to be order of 10 to the power 4. And the next is B OH whole thrice. Very interesting thing about this is the solubility equilibrium of this. If you notice that if it is S and this is 3S, so if this KSP is given as to be 1 into 10 to the power minus 33. That is going to make this question very easy. Why? Because that is the order of then 27 S raised to the power 4 is equals to KSP, which is 10 to the power minus 33. So that means S is going to be order of what? Even if you take 8, this is order of 10 to the power minus 8. And if it is order of 10 to the power minus 8, you can think about this solubility is going to be very, very less. And in presence of this, the solubility is going to be further suppressed. You must not forget that water is also going to give order of how much H and OH negative here? Any guess? Since OH negative from the other sources order of 10 to the power minus 4, then H plus should be order of what? 10 to the power minus 10. And that means OH negative, which is coming from water, is also 10 to the power minus 10. So you can immediately ignore the OH negative coming from water, and you can say that very safely that OH negative will be order of 10 to the power minus 4. So this is the most important point in this problem. Once you get the OH negative at equilibrium 10 to the power minus 4, you can quickly calculate the S dash. What will be the S dash then? 27 into S cube must be equal to what? Once you get this value, then you will simply write B OH whole thrice dissociating into B 3 plus thrice OH negative. Take it very safely equal to 10 to the power minus 4. And now this S is equal to S multiplied by 10 to the power minus 4 raised to the power 3 must be equal to the equilibrium constant, which is 10 to the power minus 33. By solving this, you will get the value of S. So this S you get, and S dash will be of course equal to what? The first equation, S dash was 10 to the power, S dash was 10 to the power minus 4. And this S you will calculate from here. And whatever value X is there, you have to find this ratio S dash by X. I hope this is clear.
Yes, sir.
Okay. So I would say that this is a very easy paper. I don't think there is any doubt here. So I will take one or two problems here. Sodium azide, I don't think there is any problem. Formula, everyone know that. This is NaN3, and then you can solve this problem. Any doubts here? What about this one? Question number 28 and 29, you can do one thing. You should always check for the zero order. Of course, it is not zero order because X is undergoing decomposition, and at different times you can notice that at 0 time and at 10 time and at 20 time, the concentration is not decreasing linearly. So it could not be zero order. So in ITJ, if it is not zero order, it could be first order or second order. For first order, you can also think about it that 0 to 10 minutes and 10 to 20 minutes. So you can quickly take a GP series, and you can also do like this: 25.6 into concentration is 10 after 20 minutes into 10 under root of this. You quickly find it out, and this is coming out to be what? 16, and that is matching this. Immediately you come to know that this is first order reaction, and then you can also calculate. So my advice in these cases are, if equal time intervals are there, you can only just by inspection and making a GP series, you can figure out what is the order of reaction. Next is question number 32. It is a very straightforward question. In fact, asked in ITJ, I don't think it take only fraction of second to complete this. Clearly, you can see that the most important reducing agent is this. So definitely this S2O8 negative is going to oxidize everyone because it is going to be preferentially reduced. So S2O negative 2 negative can reduce this, can oxidize. No, sorry. S2O negative can oxidize Cl negative, Br negative, and I negative. Everyone could be oxidized by this. Okay. And Cl2 can oxidize Br negative and I negative. So this is a very straightforward question. I don't think there is any doubt to anyone in this. Question number 33. Reversible adiabatic processes are isotropic in nature. So everyone has done this problem, that in reversible adiabatic process is a very special process. Any doubts here in this question to anyone? No doubts? Should I move ahead?
Sir, if no gas is mentioned, we take it as ideal gas or real gas?
Yeah, of course. Because where for the isothermal free expansion, okay, this D option. Yes. So your point is valid. They should have written for an isothermal free expansion involving ideal gas. Okay, this is a correction in this problem. If the answer given is ABCD involving ideal gas, you're absolutely right. Because if it is not the ideal gas, delta U will be 0. Isothermal free expansion, delta U will not be equal to 0. Delta H will not be equal to 0. Only W will be equal to 0 if the gas is real gas. Is that understood? Only W will be 0. Rest other will not be 0 because as it is an isothermal process, free expansion, suppose it is a real gas, and definitely it is going to lose temperature. The temperature will be decreased, but since it is isothermal, you will have to then supply heat from outside. So Q will be greater than 0. And of course, if Q is greater than 0, delta U will also be greater than 0, and delta H will also be greater than 0. So of course, if it is a real, your objection is valid. Good, very good. So there is an objection. If you just go for it, stick to it, then we must give some correction in this. If your confusion is this, please report it to it if you have not marked it. But I think that your intuition must be telling the paper was very easy. So intuition must be telling that D option must be for the ideal gas. But of course, if it is an ITJ advanced examination, then you can challenge it. Definitely, 100%. Next question. I think Ashish sir will discuss this question number 38 about, because it involves slight, remembrance of this thing, what is in tyrosine, lysine, and cysteine. So this is another aspect of amino acid. Sir will discuss. Okay, this is based on memory. And if I will discuss, then I will have certain objections into this one, because 100% ketanic or ionic species it could not be. So in the question, absolute value of net charge of the most prominent species should be written, because the species with is having in maximum concentration, this line should has been added from my side. Okay, in paper 1. Paper 2, any doubts are there? I hope that was paper 2. Okay. In paper 2, question number 22, there are any doubts? Any objections to this answer? I would rather say no. Question number 23 was very straightforward question. Everything was given. Everything was given in this problem. Otherwise, you would have to differentiate to get this. So I don't think there is any problem here. If anyone, please tell me. I'm showing you all the problems. Question number 26 to 27, also very ordinary problem in physical chemistry. Question number 30 and 31 also saw that. It's very easy problem. Just apply the POC and you can get. Any doubts are there, please ask me. Sir is also waiting. And question number 36 is an interesting question, because they have asked mixed together in presence of HCl to form I2. They have asked KCl, don't use equivalent concept, just use the mole concept. That is the idea. And by the way, if there is a disproportionation or conproportionation reaction, my advice is always use the mole concept. That is a better way of solving the problem. And this problem is just highlighting this fact. If anybody is going to use your equivalent concept, is going to get the wrong answer, because HCl is only the excess component spectator ion. So you could not talk about the equivalents of HCl. So you will have to virtually balance this equation to get the moles of HCl. Question number 37. I think any doubts are there?
37.
37. In 37, what you need to do, first of all, in P, you should be using this formula that Z is equals to V real upon V ideal. But then you can change it now. D density ideal upon density real. So the real density is what? 20 grams. And ideal density you calculate. D ideal you calculate, okay? And D ideal is nothing but D is equals to PM upon RT. So using this formula, PM upon RT divided by 20, quickly ascertain the value of Z. It's coming out to be less than 1. So definitely P option is more compressible since Z is less than 1. Q option is nitrogen gas at 2 atm and 273. You can virtually look it out that ideal gas would have taken 11.2 liters, but it is taking 6 liters. You see this? So ideal gas would have been taking 11.2 liters. So volume is less. So clearly there are more attractive forces operating. So there also the Z should be less than 1. About R, gas A is at critical temperature and pressure less than the critical pressure. When you see critical temperature, this is very close to, liquefaction, very, very close to liquefaction. Obviously, that is going to be a huge deviation from ideal behavior, and gas would be more compressible. Because a rough idea is critical temperature is 100 Kelvin. In the last class we have discussed, then Boyle's temperature is nearly 300 Kelvin. Their gases behave like an ideal gases. So 100 Kelvin, nearly 100 Kelvin, they're going to behave like what? They're going to behave like more compressible, a lot of attractive forces are there. So our option, you can simply look and you can say that is going to be less than 1. And regarding the S option, CH4 gas at 333 Kelvin, of course, this is Boyle's temperature and in low pressure region. So you remember the phrase, at the Boyle's temperature for a considerable range of pressure, Z is equals to 1. So obviously, this is a very straightforward question. Apart from this, all are the correct answers. What was the doubt with Prakash?
Yes, I forgot to convert grams into kilograms in P option.
Okay. So these are the silly mistakes you should be avoiding, because if it is 20 grams per liter, unit will be strictly that chemistry value unit. P pressure volume R should be taken as 0.0821. Had it been okay. Otherwise, the pressure will be taken in the pascals now. Done. So that is it. Please don't do any mistakes in such, if such simple questions are there, they are going to be deciding factors. because then you could not afford to lose any such marks, because you have more pressurized when the paper is easy. When the prepare paper is difficult, one or two questions, if you are mistaken, that will be compensated. Okay, but slightly if these kind of easy papers are there, take a long deep breath and decide that you're not going to lose any marks in chemistry, and that too within a stipulated time limit. So I think that Ashish sir is waiting. So that is it. This paper.
Sir,
Thank you very much.
sir, what are STP conditions we take now?
STP condition is as usual 273 Kelvin and 1 atm.
Molar volume 273 or 298?
No. Always 273. STP 273. Please don't experiment, because a lot of confusion is there due to this online educators. So they started differentiating between NTP and STP. Don't do that. JEE NEET standard examination is not going to talk about the NTP. NTP is only fig of imagination. Okay, these online educators have to just create, lot of buzz. For that, you can do anything. So please forget it. STP is simply that old same STP to 273 Kelvin and 1 atm.
One
Okay,
ATM or one bars?
still we are still living in chemistry, we are still living in old world. Still you should take 1 atm. Even if the ITJ is there, if they're taking 1 bar, then clearly they will write it, and they'll write it very boldly, see the instructions very clearly. Okay, still in most of the books and ITJ also using that. And actually atm and bar has very little difference. What difference it is going to make? 22.4 and 22.57. So atm and bar are very close together. But in all the standard books in physical chemistry, Peter Atkins and all this, all international books, they have already adopted it into 1 bar. Last 20 years, they have been doing this. But in Indian writers and competitive books, we have still not adopted it, because then we will have to change all the questions. And the question banks in the chemistry has been written 30, 40 years back. And that is going to be a Herculean task, you very well know. So I think that many times ITJ is also asking that question. But if they're asking it, if you see Pascal anywhere, be very careful, because then you should remember this value of R, which is 0.008. If you can see also 314, that will be perfectly in what? Liter, bar, Kelvin inverse, mole inverse. So wait for that time when they are going to give R like this. You always see R is equals to given as 0.0821 liter ATM, Kelvin inverse, mole inverse. So be careful about this. If the data is given in the instructions, check for it. And also, if they are giving pressure in Pascal and volume in meter cube, be alert. Then they are talking about the STP condition. Then they are going to be probably talking about the standard STP condition. Okay. I will discuss more in physical chemistry class. Okay. Thank you.
This is paper 1. Okay. Bachcho, first I'm discussing this paper 1, right? So in paper 1, question number 22. Anyone is having doubt in 22? That question is just easy only. You need to simply check by removing the H, that where the radical is more stable. And radical can be stabilized by even plus M, minus M. Both can stabilize the radical. Any lone pair species adjacent to radical, they can stabilize the radical also. So in question number 22, anyone is getting doubt? In question number 22. Okay. Question number 23. Anyone? This question is a bit different. That actually this kind of question is given in Claden basically. This question is based on the chair confirmation. Should I discuss this question?
Yes.
This question is a bit tough also. If you don't know about the concept, then the question become tougher side. Should I discuss this question? 23.
Yes, sir.
Okay. Beta, in this question, what you need to do in this question? First, you need to draw the chair confirmation. Okay, just give me a second. I'll just add one page here. Suppose what the structure is given, I need to just copy. This is the question, right? Now I'll explain this. First question, both are dash dash, means the both OH and B are in the cis position, and methyl with respect to these two is in a trans condition. So I'm just drawing the chair conformation here, right? So in this chair conformation, I'm writing here like Br and OH in the cis manner, up. Both are cis. With respect to Br, methyl is on the third position. So axial up, axial down, axial up, axial down, equatorial. So methyl should be like this. This is the chair conformation, right? Another one I'm writing here, like this is the chair conformation again. Here I'm writing this Br. Oh no, this time Br and OH in the trans condition. One is a wedge, one is a dash. So Br now equatorial down. This is equatorial up. And this Br and methyl, they are in a cis condition. So that methyl should be like equatorial down. So both become down. So it becomes cis condition. First, you should know about these configurations, what I'm writing here. BOH and BR same side, like dash dash. So cis. So this is up, this is also up. Up, they both are cis. Methyl, methyl. Oh, sorry. Methyl should be like a wedge. So these two are in the trans condition. So methyl should be downside. This is the case, right? Now the point is very much clear. These two are cis, methyl is a trans. Here Br and OH trans, and Br and methyl are cis, so both are down. This is the scenario. Now, as you apply this Ag2O, as per the question, what the option they have given, it is clearly seen that they are removing the Br, right? So as you remove this Br condition, right, as you remove this Br condition by AgNO3 like condition, so Br is axial, right? So its anti-bonding will become like this is the condition like this. As Br is moving out, anti-bonding is getting empty. So this anti-bonding parallel is H. So H will migrate here. As this hydrogen will migrate, so the condition will become H is migrating in the empty side, and there we are getting cation. That cation will give backup from the oxygen lone pair. So here I am getting this double bond O, this methyl as it is. In this case, when you are removing the Br, now Br empty orbital is like this. You must remember, whenever you are migrating, the anti-bonding and the migrating species should be parallel to each other. This is the basic rule in organic chemistry. You got my point? Whenever you are, like, suppose having any backup condition, so the anti-bonding and the migrating species both should be parallel. For this anti-bonding, the parallel bond is this one only. So when you are, suppose, removing this Br, which is on equatorial, its anti-bonding is like this. For the anti-bonding, parallel bond is this one. When this one, suppose, is migrate, when this one, suppose, migrate, the bond, now the ring will actually get contract. When you are, suppose, migrating this one, the ring will become contract. Now 1, 2, 3, 4, 5, ring become 5 member, and here when you are getting cation, this will get backup. So now in this case, you will get this 5 member. Okay, I'll show this in the same manner. I'll show in the same manner. Like this. Here we are getting this C double bond O and this, and here we are getting methyl. So 1, 2, 3. Oh, sorry. This is the anti-bonding. 3, 4, 5. This will actually get attached. This will actually get attached here, and here I will get this C double bond O, and here I will get methyl. Now I think you are getting my point. So in this way, we are having 1, 2, 3, 4, 5 member ring, and at this member ring, we are having this CHO condition. So I am getting the compound like here, suppose CHO at 1 number carbon, and third number I am getting this methyl. So in this case, whenever Br is suppose equatorial, its anti-bonding is parallel to this bond. So this bond will migrate. Whenever anti-bonding is like axial condition, the axial group will migrate. So in this case, ring become like a 6-member only. In this case, ring will become a contract. So here we are getting 5-member ring answer. Here I am getting the 6-member ring answer. As per the question, first option is a 6-member ring. So first 6-member ring is this one only. Oh, where's it? Oh, they are already eliminated. The C is the only option. And the second ring is contracted. Actually, in Claden, this question is differently given. They should not ask this question actually, because Ag2O can also oxidize this alcohol. So in Claden, the question is given for basically pinnacle type case, that NH2 and OH with some group species with NaNO2HCl. There the picture is very much clear that only NH2 will react. So that is the only confusion. But as per the option, we can easily identify, okay, they are removing the Br. As per the option, we can easily, there should be no confusion. As per the option, because Br has been removed, so we can easily identify they are removing the Br and playing the game with the question, right? So this is the way how to solve this question. This is the game based on the confirmations. This is a cis condition as compared to methyl, which is a trans. These two are trans, Br and methyl are cis. On that way, axial and equatorial way, the complete question is designed, right? You got, bacho? Now can we move to the next one? Okay, this question number 26, 27. You want discussion? This question number 26 and 27. I will wait. Once you respond, then only I'll discuss. 26, 27. The question is very much easy. If you have any doubt, you can discuss with me. Okay. Question number 34. You remember last lecture, Black Book, I asked the same question almost from Morrison Board, if you remember. But you
Yes,
remember? After nitration, we cannot do acylation. After nitration, we cannot do alkylation. So here the case, after acylation, we can do nitration, and then the COCH3 part will oxidize into COOH. First acylation, then nitration, COCH3 part will do haloform reaction, become COOH like. So C and D both can be answered. But in this case, they have done one small mistake, that is okay. They should simply write the workup condition, H plus workup condition, they should mention here. Otherwise, that will be the salt of COO minus. That okay, but they have given salt. Okay, then it is okay. C and D both are the answer. Should I discuss this question, C and D? C and D, should I discuss? Okay, sorry. This question 35. This is also in actually this book, the same question is given. Should I discuss question number 35? Bacho? Question number 35, should I discuss? It's just easy question only. If you say, I can discuss. Anyone? You can ask if you suppose you have any
second
doubt.
options.
Second option. Second option, this B1 beta.
Yes.
Okay. So P2 is basically N value 3. N value 3, if I place, I'll discuss you one more thing because you are asking this decarboxylation type condition. Na? Or heating condition, right? Okay, I'll discuss one simple idea. I just want to discuss with you how to solve these kind of questions. I'm starting with this one number, so you can easily get my point. This is suppose malonic acid. Whenever they ask suppose for heating, the easiest way I'm telling you, the real way is actually single step process, but I'm telling you in the easiest manner. Whenever such condition, whenever any question given with the heat sign, the sign is simply indicating that there is no reagent, whatever the reaction proceed, the reactant will only decide the process. You remember one thing only, that what the point I'm discussing, it will be very useful in your JEE advanced paper. Whenever only heating sign is given, you simply you just understand the point. Okay, now the reactant will only drive the process. When reactant will drive the process, you have to simply check which electronic effect will drive the process, because whenever the responsibility is given to the reactant, only the electronic effect will decide how to proceed the process. Whenever you see which electronic effect is deciding, which electronic effect is deciding the like a react process, then simply check what the reactant can maximum do. Reactant can maximum do the resonance here or downside. As they do resonance, this H may become like free. So the condition you can easily manage like C double OOH, and here you can write C double bond OOH, right? As this move in resonance, this O will provide backup to the H. The easiest way I'm telling you, C double bond OO minus, finally here you will get COH positive and OH. I'm breaking the reaction in parts. Now simply check this O minus is acting as a nucleophile as well as a base. If you act as a base, that doesn't make any sense. You will again go back to the reactant condition. If you think about nucleophile, so if you think nucleophile, so 1, 2, 3, 4, this is the electrophilic side. You can't attack on the electrophilic side because 4-member ring is unstable. Now what is the way? Now simply go for the driving force. As driving force is a C double bond O formation. When you double bond, provide double bond here, this CH2 become minus, this CH2 minus give backup here, and pi bond shift. You will get the situation like double bond C OH and OH. This is the enol condition. Simply tautomerize the condition, you will get CH3C double bond OOH. It means the answer is acetic acid. Now you increase the number of carbon. Suppose if I increase number of carbon 3, now C double bond O again become O minus, that will become COH here positive, here OH. First act as base, doesn't make any sense. Act as nucleophile. So 1, 2, 3, 4, 5, 6. Yes, 6-member ring we can easily generate. Now we are getting CH2C double bond O, this O, CH2C OH, this will attach gem diol, water will release, you will get the compound anhydride. You will get the compound anhydride. Now they have increased number of carbon 4. So 4 times CH2. C double bond O minus, same like previous condition. OH and OH, this is a positive. 1, 2, 3, 4, 5, 6, 7. 7 ring it is not a stable one because of the distance factor. Again, provide the driving force. Driving force C double bond O minus. Driving force C double bond O generate CH2 minus. Now 1, 2, 3, 4, 5. Yes, 5-member ring we can generate. Now I am getting the CH2, 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 C. OH and OH, and this attach here. Remove the water condition because of gem diol. You will get the compound C double bond O ketone. In this way, if you think, you can easily identify your answer. Whenever heating sign, the reactant has to decide the process. And how reactant decide the process? By electronic effects. Now, if you feel the here, the number of carbon 3, you are getting the compound anhydride. When you are getting the compound anhydride by NaOH and heat condition, you can simply hydrolyze the product. So yes, this is soluble in aqueous NaOH condition. You got my point?
Yes.
Very good. Okay. Now this 38 is easier one because they have the given the complete data also. Only these are the two species we can simply ionize in aqueous condition. This aqueous condition, this value I think also has given higher side, I think. This one is lysine. Na? Yes, that will also protonate and that will lose acidic H. That will also protonate. So 2 positive, 1 negative. That charge you will get. 2 positive, NH3 positive, and C. Yeah, that question is the easier side only because they have given the table. And this is done only. On very less questions are there, only 5-6 questions. Any question we have left? Okay, okay, I'll move to the next one. Where is the next paper? Chemistry, paper 2. Now I'm discussing, bacho. Paper 2, this 24 question, anyone got doubt? This language is actually, when I saw this language now in morning, this not perfect one actually. Proceed through free radical. Instead of this, one of the reaction intermediate in the same actually intermediate, we get radical as well as anion. So they should not write like this. It should be like anionic free radical. If they write the statement anionic free radical, that is a more appropriate word actually. JEE, I think they should not write this word, proceed through free radical, one of the reaction intermediate, then they should not write like this. Proceed through anionic free radical is the most appropriate. But anyway, this option may correct actually. Anyone got doubt in this question 24?
First one mechanism can explain.
Yes, that's very easy. This is Birch reduction beta. Suppose we have this condition like RC triple bond CR. This is the condition. Sodium with liquid ammonia. Now simply think, this is liquid ammonia is simply like a solvent here. Sodium, simply think that what the metal can maximum do. All the metals have a single tendency only, that they release electron. All the metals have single tendency, that they always release electron. When they release, suppose electron, they will give electron to here only. When pi bond may shift, the condition will become RC minus double bond C radical and R. This is called anionic radical. How this radical anionic condition exists? They should be in the opposite direction to avoid the repulsion between electrons and electrons. Now, because you have medium of liquid ammonia and carbon ion is a powerful base actually, that will give backup to H and release this, it becomes suppose CH double bond this, here we got radical and this. Now again sodium have tendency to release electron, that will give electron to this radical again. That radical again becomes suppose anion, that anion will again take H from ammonia, the compound become a transalkene. Right, now you got this first mechanism. You must remember basic thing, that sodium is simply having tendency to give electron. So give electron to alkyne condition, pi bond shift. Anion radical, simple idea, basic sense. Anion radical should not be in the same direction to avoid the repulsion. So opposite direction. Carbon ion is again simple idea, the powerful base, give back up to H, becomes CH. Again sodium give back up to the radical, again anion take H from the ammonia, because powerful base carbon ion is there. Again you will get the transalkene condition. Any doubt is there in 24? Should I move to the next one, bacho? Tell me who asked this first like mechanism. Should I move?
Yes, sir.
Okay. This 25 question, anyone stuck in this 25 question? All are very famous reaction. First is also phenol formation reaction. Second is a Dawes process. Third is a diazonium. Fourth one is a cumene hydroperoxide. Should I explain any one of the reaction? All will give phenol only. No worries. You just tell me which option I need to discuss, or all 4 options I should discuss. Tell me. No? Your wish. Question number this 28, 29. Should I discuss? What is this?
29, sir.
29. Okay, let me read first. This is a dehydration process, then ozonolysis. You will get one aldehyde, one ketone. Okay, aldol condensation you will get. Okay, so R, they have only given R answer. So R should be like this only. Then only, okay. They have directly mentioned what is R. So no need to actually solve this first step. When they are giving this, I already got this R. Now, what they're in 29, they're asking number of sp2 hybridized carbon atoms present in the final major organic product S. Okay, they're asking S. Okay. The number of sp2 hybridized carbon atoms present in the final major organic product S. As they're asking oxidation. Oh, yes. This is not the normal oxidation process. They have asked the rearrangement process actually. Okay, I'll tell you. This is not the general oxidation process actually. They have asked something tougher side. Okay, I'll show you. First, you should know the simple oxidation process. Then you can easily understand my point. Suppose I'm explaining from the basic part only. Suppose this is any alcohol. Here they have mentioned, let's say CrO3, right? How the reaction actually proceed, alcohol attack on this, we get the compound like this. OCr double bond O, pi bond shifted now, OH and double bond O. This O give back up to H release electron, this will shift and we get simply answer aldehyde. We get this simple answer aldehyde. So in this way, actually alcohol oxidized to aldehyde. You got this basic mechanism idea? Now I'll explain the process, what they are asking. They have given this R condition methyl and OH. Now if you attack like CrO3 like this, alcohol will attack, pi will shift, you will get the condition like this R. Here we have this O and Cr. This is OH, double bond O and double bond O. Because tertiary alcohol cannot oxidize, the reaction should stop at here only. But because they have given double bond and they are asking the product, now what will actually happen? This O will give back up to this pi will shift here and release this oxygen. You will get the condition like double bond R here and here O, then this O, then this Cr, then double bond O and OH. Remove this bond. Here we have H. Now this oxygen give back up to H release electron here, and this will actually move out. Now you will get the compound like double bond O. In such case, sp2 hybridized carbon are 1, 2, 3. What they have asked? sp2 hybridized carbon. Answer, what is the answer given? Bacho, what the answer they have given? 3.
Sir, 3.
3 only. Right. Then this is the way. This is not the general method actually what they have asked. JEE won't ask this case actually. JEE never asked this case. If you don't know about this oxidation by rearrangement process, you can't solve this question actually. You got this question, or should I explain again?
Understood, sir.
Very good. Now, what is this? Oh, chemistry in everyday life. Acha, I didn't see this paper too. Okay. Tranquilizers are a class of chemical compound used for, okay, this question actually I didn't see that time. Okay. Oh, okay. You know tranquilizers? Tranquilizers for just like you can say to remove the anxiety, stress, like that. So for sleeping pills, for that purpose, we use tranquilizers. Anxiety, stress, like yeah. Because in body, noradrenaline is a neurotransmitter. Actually, that will give a feel of well-being or happiness. When this noradrenaline degrade by some enzymes, so its level get down. Once the level get down, the people feel depression, negativity, anxiety, stress. So actually, we give these type of medicines, iproniazid. What the medicine do? They don't increase noradrenaline. What the enzyme who is degrading the noradrenaline, they destroy that enzyme actually. So that enzyme should, and body again reproduce the noradrenaline. So they will never produce noradrenaline. They actually damage or destroy or inhibit that enzyme which is decreasing the level of noradrenaline. So they are enzyme inhibitors. Iproniazid is enzyme inhibitor, right? And which tranquilizer is synthesized by condensation of urea and diethyl 2,2-diethyl malonate. Okay, malonate. So diethyl, it means both acid become ester, and 2,2-diethyl, 2,2-diethyl. Now they are using this urea. They are using urea. That's very simple here. Attack here, O minus, come back, remove this OET. Attack here, O minus, come back, remove this. So you will get a C, ethyl, C means ethyl, ethyl, this C double bond ONH, C double bond ONH, C double bond O. Hey, this is veronal. This is a veronal, the derivative of barbituric acid. A compound should be veronal. Yeah, this one is good. That type of many questions actually I have prepared. If you want, I can discuss in next class only. Chemistry, I have prepared many questions of chemistry in everyday life related to the phenol, alcohol, amine chapter. That many questions I have prepared. If you say, I can arrange one session for those type of questions. This 38 questions should I discuss? 38. 38 you need discussion? Okay, right. No worries. Okay, bachcho. Then anything you want to discuss, or you are getting late for your class? Can we close this session if you have no doubt?